Hey, Plumber Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hey, welcome to this presentation of Mathematics for Plumbers and Pipefitters. My name is Thomas, and in this presentation we will be going over Unit 24, which is the 0.707 constant in 45-degree pipe assemblies. Let's get started. Now in Unit 24, they point out that you can use a 45-degree fitting along with a Y, and that can create a 90-degree turn. That Y is going to come off on a 45. The 45 fitting straightens that out, so you end up with a perpendicular 90-degree change of direction of the pipe with those two fittings. We've seen that on some of our past exercises. Now they go on to say, in preceding units, the center-to-center length was found by first determining the offset and multiplying by 1.414. We're well familiar with that constant by now, right? You have your 45-degree triangle. You have the offset and times that by 1.414. That's going to give you the diagonal of the triangle. Now the diagonal, or center to center, is found. They're going to give us the diagonal and multiplied by 0.707 to find the offset. This is how we can revert back. If we have the diagonal, we can figure out the offset. The rise or run length of 45-degree diagonals is equal to the offset. You're familiar with that triangle. Let's jump over to data table 20 and have a look. Examine this with me. We are at data table 20, constants for 45-degree fittings. This is the portion on the top of that page. On the left side, we see vertical offset. The pipe is coming up from below. 45-degree fitting sends it onto a diagonal. The diagonal crosses over the offset and then straightens out with another 45-degree fitting. You're familiar with this triangle by now, right? We have the offset on one side, the shorter side of the triangle, and on the right we have the rise. You'll remember that the offset and the rise are the same length on a triangle with 45 degrees. Now here's the great part. They have written on the right side for us our constants. You're familiar with the 1.414, but let's zoom in here on the diagonal measure. Both the rise and the offset can be found by multiplying the diagonal by 0.707. This is a constant. You can rely on it. It will always give you the right answer when you're dealing with 45-degree triangles. That said, let's have a look at this sample problem. It says solve for center-to-center and end-to-end lengths of threaded pipes J, K, and L. Very familiar to us, but as we look at this diagram, you can see that we have L is at the bottom coming across horizontally, J is the diagonal between 45s, and K is from the 45 up to the 90 on the top. It's turning a 90 using two 45-degree fittings. What is given to us is the J measurement. Now if you'll notice, what is given to us is the J end-to-end measurement. We are working entirely in reverse this time. Because they give us the end-to-end, we're going to have to find our center-to-center by adding back our fitting allowances. So we'll go and we'll figure out our center-to-center. Then from the center-to-center, we can figure out L and K. We will dig into the details of this sample problem momentarily, but let me just talk through this while we're looking at the diagram. And of course, as always, while we're talking through the entire sample problem in this video, feel free to have your book open in front of you looking at the diagrams. But let's look at J. We have that 6 inches, which is our end-to-end. We've got to add those fitting allowances. Once we've done that, we're going to end up with 7 7/8. Well, from there, we still need to figure out what that offset is. We can take 7 7/8 and times that by 0.707, that's going to give us 5 9/16. From there, we can start to figure other things out. For K, we're going to subtract off 5 9/16, and that's going to give us a center-to-center measurement of 10 7/16. Once we have the center-to-center measurement, we can then deduct for our fitting allowances and figure out our end-to-end. Similarly, for pipe L, we're going to take that same offset, and it turned out to be 5 9/16, and we're going to subtract that from 21, which we have across the bottom. 15 7/16. When we subtract for our fittings off of that 15 7/16, then we can find our end-to-end. Hopefully that makes sense as we look at the diagram and how we figure out our different parts for J, K, and L. Let's go have a closer look at our fitting allowance deductions and solve this whole sample problem. All right, let's step through this. If we solve for J, we're given the end-to-end measurement is 6. We go back to data table 5 and we're looking at our 45-degree fittings for our 1.5-inch threaded pipe, and we're going to find that our face-to-center measurement is 1 7/16, and we're going to subtract off a half for where the pipe threads into the fitting. So let's look at this. We've got center to center equals 6 plus, remember we're adding this time our fitting allowances. Most of the time we're subtracting, but in this case we have to figure out the center to center. So plus, in brackets, 1 7/16 plus 1 7/16, that's for both of those 45s, that's the same, minus 2 times 1/2. As we crank that out, we get 6 plus 1 7/8. And that's going to equal 7 7/8. So that's where our 7 7/8 comes from for our J center-to-center measurement. Now let's solve for K. To figure out the center-to-center for K, we know we have 16 coming down the right side, but we need to subtract off the offset. So we take that diagonal, which is 7 7/8, convert that into a decimal, and times it by 0.707. That's going to give us the equivalent of 5 9/16. So our center to center for pipe K is going to be 16 minus 5 9/16. That's going to leave us with 10 7/16. Now we need to figure out our end to end. So we'll take that 10 7/16. We're going to subtract off our fitting allowances. We go to data table 5 to figure out what those fitting allowances are for a 1.5-inch threaded pipe. We find that 1 15/16 is our face-to-center measurement for the 90, and we're going to subtract off a 1/2 inch for the pipe threading in. Then we still have the 45 that we've looked at before, and the face-to-center measurement on that is 1 7/16 minus a 1/2 inch for the pipe. Let's look at this. End-to-end measurement is then 10 7/16, which was our center-to-center, minus our fitting allowances, in brackets, we have 1 7/16 plus 1 15/16 minus 2 times 1/2, which equals 1. That's going to be 10 7/16 plus 2 3/8 of an inch. And that will leave us with 8 1/16 for our end-to-end measurement for K. Finally, let's have a look at pipe L. We go to data table 20 and figure up the offset like we did before. We know that was 5 9/16. We're going to subtract that from our 21. Coming across the bottom, we had 21 minus 5 9/16. That's going to leave us with 15 7/16. Let me just point out there's a little bit of a typo. Missed the 1 here. Let's add that in. It is actually 15 7/16. That is our center-to-center measurement for pipe L. Now we know how to figure out our end-to-end. We're just going to subtract our fitting allowance. This is the same fitting allowance that we just figured out on pipe K. So probably don't need to go through that whole thing again. Let's just plug it in. End to end equals 15 7/16 minus, in brackets, 1 7/16 plus 1 15/16 minus 2 times 1/2 of an inch, which is 1. That's going to give us 15 and 7/16 plus 2 and 3/8. And finally, we will have 13 and 1/16 is our end-to-end measurement for pipe L. So what are we leaving out in all of this? Well, we're leaving out all of that little like conversion of fractions to get the common denominator and borrowing from whole numbers to help our fractions be able to subtract and things like that. You can do all of that, or as I mentioned before, you can use a calculator, crank those out. But remember, you might need to be going back and forth between decimal and fractions in order to make this work. That said, we just have one sample problem this time around. You're already used to calculating for J, K, and L and finding center to center and end-to-end measurements, and that's what you're being asked to do on exercise 1. On exercise 2, you're going to have a similar diagram, but this time you're solving for M, N, and O. And again, remember, they're starting us out on these with the end-to-end measurement on the diagonal. That's our starting point, just like we did in the sample problem. Finally, you'll do exercise number 3. This one's a little bit of an expanded version, building on what we learned last time on how we can figure out center to centers for Y's when they are in a series. So this one's going to be a little more involved, but you're going to be solving for P, Q, and R, S, T, and U, using what you know in the diagram and starting with those given end-to-end measurements between the Y and the 45 on the diagonal of a triangle. Good luck with your exercises. You can do this. If you need help, go back and watch the sample problem here, or even you might peek back at Unit 23 where we covered some of how to figure out those Y's in a series. And I will see you next time.